Consider this problem of solving the LPP graphically. Right, let us consider the first constraint as an equation. I am taking it as an equation to draw a line on the graph. Right, I need 2 points to draw a line. And when you put x2 equal to 0, you will be left out with x1 is equal to 50. So the points are x1 comma x2 0 comma 10 and x1 comma x2 50 comma 0. Now consider the second constraint as an equation. 5x1 plus x2 equal to 50. Put x1 equal to 0, you get x2 equal to 50, and put x2 equal to 0, you get 5x1 equal to 50, that is x1 equal to 50 by 5, that is 10. So the points are x1 comma x2 0 comma 50 and x1 comma x2 10 comma 0. So I understand that the maximum value that is required on the graph is 50 and the minimum value is 0. So let us go for this scale. Let me consider the first constraint. The points are 0 comma 10 and 50 comma 0. The line is x1 plus 5x2 equal to 50. This line divides the graph into two parts, one area above the line and one area below the line. Let us take origin as the testing point and go to the question. Put 0 for x1 and 0 for x2. You get the answer as 0. The question says, the constraint says your answer should be greater than 50, but you are getting a number less than 50. So put an arrow mark in the opposite side, right? Then 5x1 for the second constraint, the points are 0 comma 50 and 10 comma 0. Write the equation 5x1 plus x2 equal to 50. Take origin as the testing point. Put 0 for x1 and 0 for x2. You get an answer greater than, you should get an answer greater than 50, but you are getting an answer less than 50. So origin is not satisfying the condition. Put an arrow in the opposite direction. So your region should be above this line and above this line. So this is your region. Your region is unbounded. But you know, when the problem is of minimization type, the corner which is close to the origin will give you the optimum solution. Even though region is unbounded, you should not say that the solution is unbounded because the problem is of minimization type. So you consider the corners which are visible. So A, B, C are the corners which are visible, right? So what is A? 0 comma 50. What is B? You should solve for it. What is C? 50 comma 0. Now let us solve for your b, right? See, I have named this as a, this is b, and this is c. So your a is 0 comma 50, c is 50 comma 0, b lies on this line and this line, right? So the lines are x1 plus 5x2 equal to 50, 5x1 plus x2 equal to 50, right? So let us go to equation mode. Two unknowns are there. x1 coefficient is 1, 5, 50. And for the second constraint, a2 is 5, 1, 50. So I get 8.33 for x and 8.33 for y. Okay. So now let us compute the value of z, which is 2x1 plus 3x2. I get 150. Z is equal to 2 into x1 plus 3 into x2. Let us compute this. 2 into x1 plus 3 into 0. Right? Let us compute this. 41.65. So I want the minimum value. So this is minimum. So you say your answer is x1 is equal to 8.33, x2 is equal to 8.33, and the minimum value of z is 41.65. Okay, fine.